and I'll switch to my presentation. I'm going to talk about Kubernetes buzzwords, everything you wanted to know but never dared to ask. Okay. So, oh. Okay, great. So this is my session, Kubernetes buzzwords, everything you wanted to know but never dared to ask. So hi everyone, thank you for joining us as well. So my name is Idan Shahar. I'm a cloud solutions architect. I work for Microsoft. Actually, I used to deliver this session on a physical stage, and that's kind of a little bit tough for me now because mostly when I'm on stage, one of my hobbies is actually to collect shoes. So I have many pairs of shoes, and I mostly when I'm on stage, I actually show my shoes and I'm telling the audience the next talk, make sure to look on my shoes because it's going to be a different pair. So this time I cannot do that, and I'm sorry for that. But also I really like to cook meat, and the interesting thing about the methods that I use to cook meat is that I basically use technology to cook meat. And so I'll talk about, for instance, I have my smoker. I use a smoker to smoke meat. It's a specific method that gives like that smoky taste to the meat. It takes hours. But the interesting thing about that is that my smoker is actually an IoT device, that I can actually connect my smoker to my Wi-Fi, and I can control it from my phone. So I don't have to necessarily stand near the smoker to check out what's going on with the meat. I can monitor the meat temperature or the smoker temperature straight from my phone. And that's a nice spot where my technology passion and my cooking passions comes together. So as I said before, I'm a cloud solutions architect for ISVs. Let me just spread a word about what am I doing in Microsoft. As part of my role, I'm part of an organization for Middle East and Africa that's mostly do partnership with startups and ISVs. We really believe in Microsoft that when we take a startup company and we work together, and we accompany them, we help them to penetrate a new business, we help them to go to market, and as well as we help them in the technology side to build their products on Azure, they can be more successful. So we actually we're going together, we're working together, and we help startups to work and be successful together with us. And we believe that once a startup is successful with our products, we are successful as well. So with that, I'll step to my contacts. You can basically reach out to me in every single medium. I'm available. I really like to help with technology. And with that, I'll actually jump to the session itself. Sorry for that. Okay. So this session is about Kubernetes buzzwords. So are you ready to hear some Kubernetes buzzwords? You know, Kubernetes has actually become really, really popular these days. Not actually these days, but Kubernetes became like a really mainstream platform for cloud native applications. And the interesting stuff about it that it brings a lot of different technologies and innovations around Kubernetes, and it brings a lot of questions. It becomes how to follow new projects, to follow new initiatives. How do we know which kind of projects are really good for us? How technologies we should use? That's not easy. And you know that you're not alone in that. I see a lot of customers, a lot of people that I talk with raising these questions. How should I know if I choose Istio or service or a different service mesh, Linkerd, Solo IO, or how do I do security with Kubernetes? So that brings a lot of questions. So my session here is actually um, I want to walk through some specific products. Something wrong with my presentation. It's kind of something wrong with the display. I don't know. So the idea here is actually I'm going to walk through specific products, and I want to show you why should you use it, how you should use it, and when, because not all of them are actually GA'd. So let's start. I actually start with I'm going to talk about Cloud Native Application Bundle, about Zeinab and Porter that comes together, makes it easier to use. I'm going to talk about Kida. I'm going to talk about Service Mesh Interface, about Azure Arc, and about Dapper. So let's start. Let's talk about Azure Arc. Azure Arc, actually, it's a really cool project. Kubernetes is everywhere. Kubernetes, you can find Kubernetes clusters on-premises devices, on IoT devices, on the cloud, on different cloud providers, on different machines, on different type of machines, on laptops, I said IoT before, on cars. So you can find Kubernetes clusters everywhere. But that's a little bit complicated to manage a bunch of Kubernetes cluster, and even worse when it comes to many different Kubernetes clusters. So actually, Azure Arc brings you the ability to manage everything in one central place, everything in Azure. Now, when I'm saying manage, I don't necessarily mean only for management. I'm also meaning for actually taking advantage of the fact that from now on, once you added your Kubernetes cluster into Azure through Azure Arc, it becomes first-class citizen in Azure. And from that, you basically can take advantage of a lot of existing abilities and capabilities we have in Azure. Whether it's authentication and authorization, security, log monitoring, elastic scale, role-based access control, and a lot more. So let me just jump to a really quick demo. So I'm going to show you, I have a Kubernetes cluster that I installed in my laptop using Kubernetes in Docker, and then I'm going to connect it into Azure using Azure Arc. So I'll jump to my terminal, and I'll change it to be a little bit more friendly for you to see it. So actually, I'm gonna use this command, but before I'm gonna use it, I have an existing Kubernetes cluster. Actually now it's time local devcon. So this Kubernetes cluster, I just created this in the morning in another session that I've delivered, and I'm going to connect it to Azure using Azure Arc. So it's so easy to connect it. You just need to type this command, and from now on, your Kubernetes cluster is going to be part of Azure. So let me just jump to the Azure portal to show you how it looks like in Azure. So here I have a Kubernetes cluster that I already added to Azure. And what you can see here is basically that I can apply different type of policies on my Kubernetes cluster, so I can actually decide what kind of operations are allowed in my cluster, even though this is an on-premises cluster and not in Azure. I can also look on different logs. I can set access control management and a lot more. So if I'll jump back, if I'll jump here and I'll look for Kubernetes services, I will actually find out that my Azure Arc Test one, which is my on-premises Kubernetes cluster, is part of all of my Kubernetes clusters. So as you can see, if I'll jump back to that Kubernetes cluster, I can see that this is the agent node I use. This is the Kubernetes version I use. I have only one node in my cluster, and I connected this cluster to East-US resource pool. Great. So now, actually, I want to talk with you. I want to continue. I want to talk with you about Zeinab, the Cloud Native Application Bundle. You know, everyone is doing package management. This is kind of really common these days. Almost every company is Helm, right? Um, but the really interesting thing about Zeinab is that differentiated from Helm or from other technologies, it actually covers not just the application side, also the infrastructure side. So when we talk about Zeinab, that is a cloud agnostic that helps you to deliver applications and deploy applications, and of course it's completely signed and secured. It covers all. It allows you to deploy applications all the way from the infrastructure side to the application side. So once you want to create your application, to deploy your application, you already need to set up the environment, right? You need to, if you're using Kubernetes, you need to set up the Kubernetes cluster, you need to configure it, you need to set up a database, and you need to set up a bunch of different services. So after that, you can actually deploy your application. And sometimes there's a lot of manual configurations you do. So here, actually, with Zeinab, you can automate everything and use it in one. Oh, you cannot see my screen. Thank you for that. Let me just edit it again. Thank you very much. So with Zeinab, you actually can automate everything from the infrastructure side to the application side and use it as one template. So let's just go over to see some details about Zeinab. So first of all, in order to understand how to use Zeinab and what are the different options we can do with Zeinab, we need to understand a little bit about how does a Zeinab bundle looks like. So Zeinab bundle is actually a standard. So with Zeinab, you can, so the different entities in Zeinab bundle are the name of the bundle version, some descriptions, and some keywords. Of course, credentials and environment variables. The executable image that actually tells Zeinab where are we going to deploy and what are the steps that we're going to do in order to deploy our application into the specific environment. And also, it uses because basically the installed program tells Zeinab what are the different technologies that we're going to use when we're deploying our application. So in this case, and I'm going to show you an example really soon, I'm going to use an Azure program installed program and a Helm installed program. Also, we have parameters because this is a template that should be automated, should be customized for different type of environments. So assuming you develop your application in the right way, where it can be packed in different type of ways, whether it's containers or virtual machines or whatever you want to use, you can basically make one template that can fit different type of environments. Okay, great. But the thing with Zeinab is that it's kind of complex. You need to learn a lot about how it's built. You need to develop a lot of stuff. The way we should use Zeinab is actually using Dapper. Dapper is a CLI tool that lets you install bundles, deploy, distribute, build bundles, upgrade and uninstall bundles. But in order to use Dapper, you need to really understand how Synapse works under the hood. And sometimes you don't really want to know how it works under the hood, and that's why we have Porter. Porter is actually a really nice YAML file that makes the use of Synapse bundles a lot easier, because you basically can put everything inside one YAML file without writing any bash scripts, no Docker files. You don't have to understand how Synapse specs works. You basically just need to write a YAML file. And let me just show you that. So here I have a Porter YAML file. In the left corner, we can see that I'm going to deploy an Azure WordPress application. I'm going to use two different mixings. Remember when I told you about installer programs? So here are the mixings. I'm going to use two different mixing. One is Azure and one is Helm. In order to use the Azure mixing, I actually need to set up my Azure credentials so that my Porter YAML file and Porter engine communicate with Azure and authenticate against Azure. Second, I'm going to set up a bunch of parameters. So after that, I'm going to use it when I'm setting up my SQL service, database service. So here we can see that I'm going to set up a MySQL database. I'm going to inject a bunch of different parameters. For instance, the MySQL user, MySQL password, the server name, the database name. And as you can see, there is the output section where we're basically telling the Porter YAML that after finishing the deployment, the provisioning, please let me know what's the MySQL host, because I want to use it. And I want to use it as part of my Helm chart. And that's where I use the Helm chart to deploy my application to my Kubernetes cluster, that in this case, it already exists. So I'm going to inject the MySQL host into my Helm chart. And that way I actually an abstraction for an environment setup. Now, the strength about using Porter is that you can take advantage of any existing, sorry for that, of any existing infrastructures, code methods you use, or anything else you use to set up your environment, Puppet, Chef, whatever you used, because this is just a wrapper. This is just a way to abstract everything and to connect the dots between the infrastructure layer, PaaS services, virtual machines, Kubernetes clusters, and everything. So with that, you basically can build the whole platform in one single command. Great. Now, we finished to talk about cloud native application bundle. Now I want to talk with you about scale, because everyone is doing scale. Scale is so popular these days, and we need to scale up and down. And there's many ways to do that. We mostly do that by a bunch of different metrics, right? We use CPU metrics or memory metrics, or in the good case, we're using some metrics that we define based upon our application metrics, right? And when our application reach its threshold, we basically add more and more containers, pods, right? But maybe there's another way to do that. Maybe there's a more efficient way to manage our cluster resources, our applications. And I'm pretty sure that someone already thought about that. How can we scale our application based upon different type of metrics that are a little bit more efficient, more smarter? So these days a lot of services are actually event-driven. A lot of applications are built in event-driven architecture. And why don't we take advantage of, for instance, of queues and be proactive and scale our application based upon the amount of messages we have in that queue that we use to communicate between different services, right? So the interesting thing about that when we have a lot of messages in a queue, we can basically add more resources to the cluster. In this case, add more pods. But when we don't have messages at all, do we need to have containers running? And the answer is no. This is where we can scale to zero our cluster. So I'm happy to introduce Kida. Kida is actually a Kubernetes-based event-driven auto-scaling. Kida lets you to scale down to zero and up from zero. So Kida actually acts like a Kubernetes metric server. So Kida can see how many messages do you have in a specific queue or any message bus you use. Or not just message buses, by the way. It also supports Prometheus, for instance. And then it actually tells the Kubernetes HPA, the horizontal pod autoscaler, to scale up and down your application. It actually changes the replica set, the amount of the pods you'll have for a specific deployment. But that's not just about that. It also can disable a specific, an existing deployment. In case you don't have messages at all and we don't have to have containers running at all, it actually tells Kubernetes, okay, this deployment, just disable it now because I don't have any messages in the queue. So that's why we can be proactive. And when we know that there's a lot of messages in the queue, and instead of waiting to our applications to blow up and to reach the threshold, we can be proactive and we can set up a lot of containers to be ready and look forward to handle these messages. Now, the way Kida does that is by actually adding a new CRD to Kubernetes, custom resource definition. So it actually tells, let's say that I have a specific deployment. It's called Hello Kida. Okay? This deployment, I want to connect it into Azure queue, Azure Storage queue. And I want to let that deployment be the amount of the pods that I'll have in that deployment. I want it to be based upon of the amount of the messages I have in that queue. And that's where this example will come to the pictures, because this shows Kida for every 5 messages I have in that queue, bring another pod. Okay? I want to let you know that it's really easy to install Kida today. You can use Azure Functions or Helm to install Kida. It also supports Helm 3. It also supports Helm 2. It's really easy to install Kida. Okay. The interesting stuff about Kida is, together with ACI container instances, with ACI you can basically drop a container, let it run on the cloud, don't manage it, don't put any effort in make it to manage it. It just works like easily. Okay, so this is and to with virtual kubelet that actually connects ACI instances into Azure Kubernetes services or any other Kubernetes cluster, you can basically create a serverless Kubernetes cluster without any physical nodes. Physically means actually virtual nodes, but it's kind of confusing. Anyways, so I think we have Kubernetes cluster and we scale up our application. At some point, it reaches the limits, not just for the container limit, also for the virtual machines limit. And then in the duration, actually to add another node to the cluster, right? So with virtual with ACI, we can build a serverless Kubernetes cluster, and we don't have to worry about auto-scaling virtual machines. Now, together with Azure Functions, this is our service offering. This is our serverless platform. And together, and it also can be running on Kubernetes cluster together with Kida. We can actually build completely serverless applications all the way from the infrastructure side to the application side. From the infrastructure side, we have a serverless Kubernetes clusters with serverless nodes. But from the application side, we have a serverless application that is scaled to 0 using Kida. So in case we don't have any messages in the queue, we will actually have a Kubernetes cluster without any resources attached. And that's a really efficient way to run Kubernetes applications. So I want to show you a really quick demo of how do I use Kida. So back to my terminal. So as let me just switch to the right Kubernetes cluster. Great. So as you can see, let's make it a little bit bigger. As you can see, I have a Kubernetes cluster. I only have one pod running at the moment. But actually, if I look at my deployment, I will see that I have another deployment that is called RabbitMQ Consumer. So I actually have one deployment for RabbitMQ Consumer and another, it's not a deployment, but another RabbitMQ pod. So it is a deployment, a sort of deployment, but another RabbitMQ service. Now, actually, what I want to do now is to show, but there's no container running for the RabbitMQ consumer. So what I want to show you now is that actually how I'm gonna make this container running. So let me just have a look on my Kubernetes nodes. So I'll show you that I have two different nodes. One is the virtual node that, as I told you before, it's connected to Kubernetes cluster with a virtual kubelet, but it's not a virtual machine under the hood. It's actually it will spin up ACI instances for each of my pods. And I have the AKS agent pool that is a regular Kubernetes agent. Okay. So I'm going to push 300 messages into the RabbitMQ, into my RabbitMQ service. And I expect to see the RabbitMQ consumers starting to spin up and consuming these messages. So I'll start with showing you how I'm going to put 300 messages in that queue. So I'm going to use this little script to put 300 messages. It's actually a job for Kubernetes. So let me just deploy that job in class. So that actually just created, and I can see that actually I have new consumers starting to spin up. If I'll show you that in wide mode, you can see that these containers are actually running on the virtual node ACI. Now you'll see how fast it's going to add more and more and more containers. Because as you remember, we have 300 messages to consume. And from time to time, we will see that more and more pods are being added. Now think about that strength. Think about how amazing it could be for scale handling. it can actually let you infinite scale your application. So you don't have to worry about, oh, I just added 1,000 new users, and I'm afraid to not being able to handle this amount of usage. And I'm kidding, of course, 1,000 is not a lot. How do I do that? So hey, you can use virtual nodes. That's really easy, and it's just a matter of a node selector. Great. So I just showed you how to take advantage of virtual nodes together with Kubernetes cluster with Kida and to do that whole serverless motion inside Kubernetes. Now let me just jump back to my presentation. We're about to finish. Now I want to talk with you about service mesh. Service mesh, there's many different implementations of service mesh. We have Istio, we have Solo.io, Linkerd, HashiCorp Console, and many, many, many others. But sometimes it's a little bit complicated. So I want to show you, before we actually jump into understanding how service mesh works and how service mesh interface works, I want you to understand what a service mesh is. So a service mesh is actually a one centralized reverse proxy. But what is a centralized reverse proxy? What is a reverse proxy at all? So, let's say that I want to talk to my friend and to another friend, but I don't actually know their address, okay? So what should I do? How can I communicate with them? So imagine that there is one man that sits in the middle, that I can reach out to him and tell him, oh, listen, I want to talk to this person, and I want to talk to this person. So please send that message to that guy and send that message to that guy. And he can actually translate my message, my destination message, to the right one. So this is basically a reverse proxy for dummies. Now, think about having one centralized reverse proxy inside your Kubernetes cluster. And every single request actually goes to that Kubernetes cluster. Proxy. So that being said, we can get a lot of value out of it. Whether it's service discovery because we have one single endpoint, one single point that understands and know every other services. We can do load balancing because now we can control which traffic will go to which service. We can do service monitoring, routing, tracing. We can define policies of who can communicate with which kind of which services can communicate with each other. We can do service to service security communication. So we can actually define TLS between different services because we have now one service that every single request goes through it. We can do blue-green deployment, canary deployment, and so many different abilities we get out of that fact that we use one centralized reverse proxy. But sometimes service mesh is not that easy. And service mesh is actually a complicated service to implement. So that's where actually service mesh interface comes into the picture. So let me just say something about that project. So the Service Mesh Interface project, this is a project that Microsoft announced together with many, many different partners that are known as a really contributors to the Kubernetes ecosystem. So what Service Mesh is actually is. So I'm kind of pretty sure that most of you are familiar with the concept of ingress controllers. So we have a different type of load balancers, layer 7 load balancer, whether it's Nginx or HA proxy or the different cloud providers load balancers. But in Kubernetes, we manage it using one interface, the ingress interface, right? So think about exactly the same concept, but for service meshes. So we basically use one service mesh interface, one interface, that eventually it's translated into the specific implementation of the chosen service mesh implementation. So in case we want to jump between different service meshes, because we understand that this service mesh is better for my needs, and that service mesh is less relevant to myself because it doesn't support that. I can easily jump between different service meshes using that service mesh interface, because I basically need to tell the service mesh interface, no, I want to use this one. No, I want to use this one, and that's it. My implementation actually doesn't change. Now, I just got into my last. Oh, hello, Holly. I just got into my last topic, which is Dapper. Dapper is actually an event-driven runtime for building microservices on the cloud and on the edge. What does it mean? Building runtime for building microservices on the cloud and on the edge. It actually means that, think about it. As developers, we find ourselves, just that. We find ourselves working on really things that are not necessarily related to our core business. So, just a second. Sorry for that. Let's see. Sorry for that. So we found ourselves working on bunch of different things, developing integrations and things that are not necessarily part of our main business. And should we invest our time in developing integrations with things that are not should be our main business? Shouldn't we focus on our main business, our logic? Yes, we should. But sometimes there's no escape. Sometimes we have to develop integrations. And just let you give you an example. Let's say that we want to drop a file into a storage account, into some storage, object storage, okay? So we have to integrate with that. We have to use the SDK or the API. Sometimes we'll find ourselves writing our own library so others in my company can use it. Can you reuse it? We'll put it in the common objects. But this is not our core business. So this is where Dappers come to the picture. It actually lets you focus on your main business. With Dapper, you don't have to actually integrate your service with any single service that you use. So with Dapper, you can let me just simplify it. I gave you the example of a storage account. With Dapper, I actually use Dapper to run my application alongside or inside my application, and I'll tell Dapper, okay, this is the file. These are my credentials in this case, and please take that file and drop it into that storage account. So actually, Dapper will do the integration for us. And the interesting stuff about Dapper, because it's supports gRPC, it basically supports every single language. Great. So with that, I actually finished. So I'm open for questions. If you have any question, that's a really good timing to ask it. And if you don't have any questions, I'll jump to my last slide, where you can reach out to me. If you like my presentation, feel free to send me a message. I'm available in every single medium. You can scan the barcode here. It actually routes you to my LinkedIn profile. And you can also use the aka.ms/Idan to reach out to me through LinkedIn. So thank you very much. And with that, I'll actually remove my screen. And again, thank you very much for joining the Hackorona webinar. We will meet you again on Sunday. On Sunday, we're going to have interesting sessions as well. So have a really good weekend. Take some rest, and we'll see you on Sunday. Thank you very much. Bye-bye.